And now, Nati Amsterdam, the country director of NVIDIA Israel, will tell us about how NVIDIA Generative AI fuels the next industrial revolution. Please, Nati.
Thank you. Play po. Okay. Hi, everyone. Good to be here. So I'll start a little bit with some details about NVIDIA in Israel. Probably you're all familiar with NVIDIA. As an AI leader, solves some impossible missions. So NVIDIA in Israel, we're actually around 4,500 people. We grew, we doubled our size from 2019. We have an R&D site, very, very big in Israel, in Yokneam. And we develop here our networking gear, which is used globally, of course, as part of the accelerated data center that we build. We have an architecture team. We have a research team in Israel that is focused mainly on publication and long-term. And we are also hold a program that is called Inception, where we onboard startups on NVIDIA technology, and we have more than 1,000 startup companies in Israel only as part of our Inception program. We help them take decisions and help them really build their go-to-market and being more successful at what they're doing. We also have close ties with the academia and universities. I'm always saying that today when a new faculty member wants to join a university, it's like signing an NBA player. Okay? It comes with a list of demands. At the top of the list is supercomputing capabilities that he needs access to train and do his life research. So we support the universities, helping them build computation centers, both in each university and also with specific researchers that come to us. A year and a half ago, we announced on Israel One. Israel One is a supercomputer. Is on the top list of the supercomputers in the world, and it's used for R&D, main purpose in Israel. We're also going to open it soon to commercial use for the Israeli ecosystem to help them be more successful. So what NVIDIA is actually doing, we accelerate each industry. So it's not general purpose to understand how to accelerate a specific industry. You need to have the right people that knows the industry, that understands what needs to be done, the subject matter experts, that they actually help us identify the right workloads, the right problems that needs to be solved. So we build platforms that helps each industry to make the transformation. You will see here, the biggest one is, of course, cuDNN, which is deep neural networks. This is a software architecture that is almost in every solution that do AI today. We also have libraries like physics, AI physics, that is mainly focused on understanding, the physics, the materials, and helping them use the algorithms and software to accelerate that. But cuDF, you see everything starts with Cu because CUDA is the main architecture that NVIDIA uses to run our platforms. cuDF for data processing, CUDA-Q for quantum computing. We just recently announced an Israeli quantum computing center together with quantum machines and Israeli startups. And we actually help them run workloads, both simulate them on GPU and also run them on QPU, on quantum processing unit. Things like AI Aerial, where we accelerate 5G applications as well. And we can continue more, computational lithography and gene sequencing, how to accelerate gene sequencing, how to identify using AI to identify medical imaging and annotate organs and do a lot of things to help those radiologists be more efficient in the work that they're doing. So we need to understand that, in the last 60 years, this is the way that we developed applications. We code, we ran it on a CPU, and this is the way that we developed applications. Today, in the last 10 years, we changed that to machine learning, which means that we are using a machine to build algorithms that later on feeds the GPU. Today, we already have a lot of trained models and a lot of trained algorithms, and we need to do inferencing. We need to infer them, and we need to run them as well on GPUs and run all those neural networks on GPUs. So this is the stage that we are at. But we learn to understand language, which is not only the spoken language or understand the semantic of words. We also understand these days different type of languages. So a language can be a language of genomics. A language can be a language of brain waves. It could be a language of speech, of text, or video. A language can be a language of intelligence. It can be different type of languages that the machine can learn and understand. And we need to understand the data, and then according to the understanding of the data, we can generate intelligence. Just an example, if you take English, multimodality of English to Spanish, it's translation. If you want to do English to English, it's summarization. If you want to do pixels to text, it's image, text to pixel is image generation, and so forth. So all the options are open for us today where the machines can actually learn everything and we can generate intelligence following that. So we need to understand it didn't start in one day, okay, where we are here today. It started in 2012 with AlexNet. Professor Krzyzewski from the University of Toronto took a GPU, which was a gaming board, and developed an algorithm to identify, using supervised learning, to identify an image and being able to do that. Then in 2016, we actually delivered the first supercomputer. It's called the DGX-1. We handed over to Elon Musk, where he was part of OpenAI, which was non-profit. I joined NVIDIA at that stage, 2016, which was an exciting time for us. And this machine was used to train semi-supervised learning, which means not only images, but understanding the data. In 2017, something called Transformer came, and we actually needed to use multi-node and train in large amounts of data. I think this was a really big breakthrough where we understood we cannot use a single GPU or a single computer. We need to run larger environment. And then in 2023, this is the first time that AI really learned how to understand the human language. And we can feed prompts, and we can get answers. And this is the first time where we really had a major breakthrough. So what is the new industrial revolution? And I just heard Professor Noah Harari compare the stage where AI is today to amoeba in the human development. So this is really significant. We are just at the beginning. So what are we seeing today? So we are seeing the new industrial revolution is actually creating AI factories. And AI factories will help us to generate intelligence out of the data that we already collected. It doesn't matter where it came from which type of data. And the tokens are units of intelligence. The tokens can be text, can be image. We just explained about multimodality. And actually, it influences all of the markets, starting from science, where we see new innovations coming from science. Every day we meet researchers, and Israel is really leading in that area. Researchers that are really bringing their life work and really inventing amazing things. Through the enterprise market, which is also transforming, we see banks that are building the new commercial banking platforms that are more personalized, using avatars and using sophisticated chatbots. Through healthcare, where it's really making transition. I just had a meeting last week with a very known professor that is leading one of the research in the HMOs, who said, listen, we don't need to write anything more. We just need the machine to listen to the discussion that the doctor has with his patient and being able to take the data and do a lot of things with it. It's called ambient listening. So a lot of AI assisting tools will be involved also in the healthcare market. Of course, manufacturing is also a big portion. And as you're probably familiar, in Israel, we have close to 400 of R&D centers of global companies that are really developing their AI capabilities in Israel using the Israeli talent, and automotive, or what we used to call autonomous machines. So this is also a market that is really moving very fast with this industrial revolution. We aim at, we don't aim, but we see the market coming to $100 trillion of overall business. So each organization needs to create intelligence, okay? This is the way that, just explained in Software 1.0, this is the way that we work together. We have a software factory, we use tools, we use specific infrastructure. It's more of a general purpose. This is the way where we started in the beginning of the journey to AI. Organizations are transitioning toward the AI factory, where AI factory, it's not just building the data or the algorithm. You need to develop the skills. You need the managers or the commanders to understand what they can achieve with AI. They need to learn. I'm always saying, people ask me if AI will change people or will replace people. And my answer is that people that are using AI will change or will replace people that are not using AI. So we need to develop the skills, from managerial positions to all the people, to the, all the way in the system to develop their skills. We need to use generative AI to generate content, whether it's synthetic that we can learn from, or take decisions on the generative AI field before we are moving to the physical world. Of course, LLMs is key, and I'll give a few examples soon. LLM is large language models. ChatGPT is an example of LLM. And of course, building supercomputers that are running on GPUs to be able to support everything that we want to do. So generative AI drives a full stack reinvention. It's not just the hardware or the software or the skills. It needs to be end-to-end. That's the way to transform the way that you are doing today. That's the way that we are seeing the market evolving. So to help you do that, NVIDIA developed something called NIM. NIM is NVIDIA Inference Microservices. So these are pre-trained models that we are developing that can do things for you. We don't need each of our partners or customers to do the heavy lifting. We are doing that for you. So we develop NIMs. I'll show you an example soon. And you can take that and you can actually implement it in your organization. So just as an example, we have an API catalog, close to 150 foundation models in it, from NVIDIA and from our partners. You will find here all the large LLMs coming from whether it's Meta or AWS or XAI or any other things. And actually, it's production ready. And you can take it, you can put it in your organization, connect it to your data using RAG, and run it either on-prem or in the cloud everywhere and start to get intelligence out of your data. So NIM is the way moving forward. So you can see examples like speech and digital human and computer vision NIM and biology and simulation and language understanding. All of that is currently available. So no need to do the heavy lifting. Just take the inferencing microservices and deploy them in your organization. So up until now, we were focused mainly on training of models. Okay, training is really understanding and learning from the data. And we saw training infrastructure that are very big, like Meta, that started with tens of Ks of GPUs, up until recently that XAI bought a 100K GPU. The UAE are building up capabilities. Many countries are doing that around the world. We have a lot of partnership being built up with many countries that are doing investment and are building their infrastructure to support their ecosystem, to support the strength of their country. Recently, we just heard that Elon Musk is planning to expand to 1 million GPUs in Colossus, which is a big number. But now, with the new models that came out, like Strawberry from OpenAI, which is called O1, the models are becoming much more smart. They know how to think. And this is quite significant because, we saw a significant growth in the training of compute, but now we are going to see a huge growth on the inferencing, the prediction part of the system, the production. So think about it that a model will know how to break a large problem to smaller problems and have other LLMs solving the problems for him. So we can actually send a problem to the machine can break it to specific LLMs that will solve the problem, and eventually they will give us the thinking of a human and the ability, the recommendation, what's the best way, the best route to solve a problem. So, it can be an agent that we break it to smaller agent to do the complicated mission concurrently and find the optimal way to solve it. It can be a combination of vision, understanding, with speech, with text, with data analytics. Everyone are working together towards solving of the problem. So for that, NVIDIA actually brought in the Blackwell platform. Some people think that when we say Blackwell or NVIDIA released a new GPUs, it's a chip. So it's not a chip, it's a platform, a huge platform. This is Blackwell. Okay, this is something that we brought in to solve the new challenges that the world has. So the heart is still a GPU, but there are 7 more chips that are supporting and bringing blood to the heart. There is networking that is developed in Israel. There is a software stack. All the NIMs that we spoke about are optimized to run on this infrastructure. So if you want to build an AI factory that is energy efficient, this is the way that NVIDIA do it. So there are 2 leading mega areas that we are seeing that are going to evolve and are going to probably be here for the next few years. One of them is called agentic AI, and the second one is physical AI. What you see here is what I just described, is agents that are really smart agents that are able to build and have capabilities. We can actually take those agents, connect them to LLMs, specific LLMs. We can make them smarter. We can improve them over time. Okay? Think about all the knowledge that is being developed globally. We can feed the agent to make the agent much smarter. We can prepare the data for them, we can tune them, we can customize them, and we can deploy them as NIM everywhere. And this is the blueprint for AI applications, how we build it for the agent. So NVIDIA develops everything, end to end to help you be successful in deploying this at your infrastructure. The second thing is robots. You know that robots has been a tough problem, and now with Gen AI, we can actually make robots, smarter, more sophisticated, and do it in a shorter time, and we call it physical AI. So yes, there are big challenges, but we are seeing that field evolving. And robots will augment human, okay, and will automate for us that in a physical world. And just for me to summarize and finish, no one better than Jensen Huang, the founder and CEO of NVIDIA, to explain you in 2 minutes what NVIDIA is doing in robotics and how it can really change the way that we are seeing the world in the physical AI world moving forward.
Physical AI embodies robots like self-driving cars that safely navigate the real world, manipulators that perform complex industrial tasks, and humanoid robots who work collaboratively alongside us. Plants and factories will be embodied by physical AI, capable of monitoring and adjusting its operations or speaking to us. NVIDIA builds 3 computers to enable developers to create physical AI. The models are first trained on DGX. Then, the AI is fine-tuned and tested using reinforcement learning physics feedback in Omniverse. And the trained AI runs on NVIDIA Jetson AGX robotics computers. NVIDIA Omniverse is a physics-based operating system for physical AI simulation. Robots learn and fine-tune their skills in Isaac Lab, a robot gym built on Omniverse, and with Groot workflows like Groot Gen to generate diverse learning environments and layouts, Groot Mimic to generate large-scale synthetic motion datasets based on a small number of real-world captures, and Groot Control for neural whole-body control. This is just one robot. Future factories will orchestrate teams of robots and monitor entire operations through thousands of sensors. For factory digital twins, they use an Omniverse blueprint called Mega. With Mega, the factory digital twin is populated with virtual robots and their AI models, the robots' brains. The robots execute a task by perceiving their environment, reasoning, planning their next motion, and finally converting it to actions. These actions are simulated in the environment by the World Simulator in Omniverse, and the results are perceived by the robot brains through Omniverse sensor simulation. Based on the sensor simulations, the robot brains decide the next action, and the loop continues, while Mega precisely tracks the state and position of everything in the factory digital twin. This software-in-the-loop testing brings software-defined processes to physical spaces and embodiments, letting industrial enterprises simulate and validate changes in an Omniverse digital twin before deploying to the physical world, saving massive risk and cost. The era of physical AI is here, transforming the world's heavy industries and robotics.
So thank you, everyone. We are here to support everything that you are doing and help you be more successful. And thank you very much for inviting me.